Okay, good afternoon. So today we are going to analyze the portal frame for the actually plastic analysis of portal frame. Up to the last lecture we have seen the plastic analysis for beams, and today we are going to start, or from today onwards we are going to solve the examples on the plastic analysis of portal frame. So here write down plastic analysis for portal frame. Portal frames. Okay, so now what is frame? So actually here this is the frame. If we assume, or here we will show the hinge support. This is the fixed support. So if here any vertical load is there on beam, this value 2, again this value is W, this is the length L, this is the length L1 AB. So like this any portal frame may be there. So now for analyzing this portal frame, so we have to find how many number of minimum mechanism required to analyze this portal frame. So we have seen the beam, we have analyzed the beam. So here only one mechanism we have seen. Here only one mechanism we have seen, and that mechanism is the beam mechanism. But so now in the portal frame, so we have to calculate how many number of mechanisms required to analyze this beam, that we have to see. So here as in the beam we have seen only the one mechanism, that is the beam mechanism, but in the portal frame we have to find how many number of mechanisms required for the plastic analysis. Okay, so now, so how to calculate this minimum number of mechanism? So here we will see, so how to calculate. So for that we have to calculate first, degree of static indeterminacy. Degree of static indeterminacy. So now how to calculate degree of static indeterminacy? So degree of static indeterminacy is nothing but number of supports, number of supports, number of support reactions, number of support reactions minus number of equations, number of support reactions minus number of equations. Now here two supports are there, one is the fixed supports and another is the hinge supports. So here how many reactions we have to calculate, how many number of reactions for these two supports that we have to calculate. So if we consider the fixed supports, then here how many number of reactions will be there? So here first reaction, that is the vertical reaction due to this vertical load. Then here due to this horizontal load, here the opposite horizontal reaction will be there, and the fixed support is there. At fixed supports always movement will be there. So here this vertical reaction, horizontal reaction and movement. So here three reactions are there for the fixed supports. Okay, so another support is the hinge supports. So for this hinge supports, there are again two reactions are there. One is the vertical and another is the horizontal. Horizontal reaction due to this horizontal force and vertical reaction due to this vertical force. So here how many total reactions are there? So what is static degree of indeterminacy? So in the static degree of indeterminacy, we have to calculate static degree of indeterminacy is nothing but number of support reaction minus number of equations. So here spelling mistake is there, I will correct this. So, degree of static in determinacy. So degree of static indeterminacy is equal to number of support reaction. Now here find how many number of reactions, one vertical, one horizontal, and another is the moment. So here 3 plus other two, second support. So first support, fixed support is over. Here 3 reactions are there. Now come to second support, that is the hinge support. So at this hinge supports, how many reactions are there? One vertical and other horizontal. So 3 plus 2, 5 reactions are there. For what purpose we are doing this? We are doing for the how many number of mechanisms required to solve this frame, that we have to analyze. That's why we are calculating the degree of static indeterminacy. So number of support reaction 5 minus number of equations. See how many number of equations required to stable this frame. Anybody can answer me? How many number of equations required to stability or stable this frame? किती नंबर ऑफ इक्वेशन्स गरजेचे आहेत आपल्याला? अप्लाइड मेकॅनिक्स मध्ये शिकलाय तुम्ही, हा, किंवा सॉम 1 2 ला झाले. Yes, okay, Gaurav, correct. So minimum 3 equations are required because horizontal force is there, vertical force is there, and moment is there. So if we solve summation m is equal to 0, summation v is equal to 0, or summation h is equal to 0, at least these three equations we have to solve or we have to consider. So here 3 equations are there to stay. If we have to see or consider the stability of this structure, then these 3 equations must be satisfied. So here equations are 3. Equations are 3. So here degree of static indeterminacy, that is dSi is equal to 2. So that we have find out. Now how to calculate the number of mechanisms? So in number second, we have calculated here degree of static indeterminacy. That degree of static indeterminacy is nothing but the number of support reactions minus number of equations. So DSI we have calculated, that is 2. Now, so how many number of plastic hinges? Second, we have to calculate number of plastic hinges. See, without plastic hinges we cannot go for the plastic analysis. जर प्लास्टिक हिंज तयार होत असेल तरच आपण प्लास्टिक अनालिसिसला जाऊ शकतो. अदरवाइज दॅट स्ट्रक्चर मे बी इनइलास्टिक or determinate structure. Are you getting? So plastic hinges must be formed. Then and then we can analyze the frame or beam, any type of our structure, steel structure. If the plastic hinges are not formed, then we cannot go for the analysis of the plastic analysis. So plastic hinges must be formed. So here at minimum 2 plastic hinges should be formed in the frame. So where at this joint and at this joint. So minimum these 2 plastic hinges here supposed to form, then we can go for the plastic analysis. So this joint and this joint. Are you getting? Forget the this W load for horizontal and vertical load. Only consider the joint, this first joint and second joints. At least at these 2 position, the plastic hinges should be formed. So here minimum 2 plastic hinges should form. So number of plastic hinges are here DSI plus 2. That minimum, this 2 is for DSI is the degree of static indeterminacy. That is DSI plus 2 what? So as I told you here, 2 is nothing but here at least these 2 form. If DSI 0, जर DSI 0 आला तर हे 2 तर 2 तर प्लास्टिक hinges तयार व्हायलाच पाहिजे. Why these 2? Because this joint and this joint, at these 2 joint at least 2 plastic hinges should form. Are you getting? या जॉइंटला आणि या जॉइंटला at least these two joints plastic hinges should form. If DSI more than that, then number of plastic hinges should be increases. Now here if DSI 0, जर DSI या ठिकाणी 0 चाल असता तर 0 plus 2 म्हणजे at least 2 plastic hinges here should be there. So now here how to calculate plastic hinges? So here plastic hinges is we can calculate by using this DSI plus 2. It means DSI is 2 and we have assumed this 2 value. So 2 plus 2 is the 4. So minimum plastic hinges in this frame. In this frame, the minimum plastic hinges will be formed 4 numbers. Okay. So now number 3. Now in number 1 we have calculated degree of static indeterminacy. In number 2 we have calculated the number of plastic hinges, and now we have to calculate minimum possible number of mechanism. Minimum possible number of mechanism म्हणजे कमीत कमी किती मेकॅनिझम आपल्याला सॉल्व करावे लागतील. That we have to here find. So minimum possible number of mechanisms. So minimum possible number of mechanisms are, so here number of plastic hinges is equal to number of plastic hinges minus DSI. So number of plastic hinges are 4 minus DSI is equal to 2 . So here at least 2 mechanism we have to solve. For the plastic analysis of frame, at least 2 mechanism we have to solve here. Are you getting? So see how we have calculated the minimum possible number of mechanism. So in the first stage we have calculated degree of static indeterminacy, then we have calculated number of plastic hinges, and from this DSI and plastic hinges we have calculated here minimum possible number of mechanisms. At least these 2 mechanisms we have to solve. Now what 2 mechanisms? What are these 2 mechanisms that we will see? Are you getting? Now here how to analyze the portal frame by using this number of mechanism. So this is this हा एक छोटासा फॉर्म्युलेटेड स्टडी आपल्याला करावा लागेल बिफोर दी analyzing the portal frame. So here 2 plastic hinges, sorry, 2 mechanisms we have to solve. Okay, so now what are these 2 mechanisms? So these two mechanisms are number 1. So here number of mechanisms. So that number 1 is the beam mechanism, and number 2 sway or column mechanism. So we have seen in the type of mechanism, various types of mechanism. So at least 2 these mechanisms we have to solve, column mechanism and beam mechanism. And combination of these 2, beam and column, is the another third mechanism is there that we will solve after these 2 mechanism. But these are the minimum we have to solve, beam and column. Are you getting? So here this is the some theoretical part before the solving the actually example. Okay, so we will see the first example on this portal frame. Okay, so example number 1. Okay, so write down the problem statement. Write down, find the collapse moment, find the collapse moment, find the collapse moment for a given portal frame. Find the collapse moment for a given portal frame. So figure is given. So I will draw figure. Again, draw everyone. Everyone, please draw the figure. We have to find here. Problem statement is given. Find the collapse moment for a given portal frame. So draw the frame. So here on the beam, the vertical load is 200 kilonewton is given. That load is from this support at a distance 2 meter, and from this support it is at a distance 3 meter. So this is the vertical load. Now the horizontal load, that is 100 kilonewton, is at a joint B. This is A, this is B, C and D. Joint A, B, C and D. Now this distance is 4 meter and this distance is 6 meter. Okay, so this is the given frame. So frame is nothing but column beam structure. So horizontal members are we are calling as beams, and vertical members we are calling as columns. So column beam structure is the frame structure. So it may be concrete or it may be steel, but we are here analyzing the uh, plastic analysis is for steel only. Okay, everyone please draw the sketch. Okay, so now for this frame we have to calculate how many number of minimum mechanisms we have to solve. So as per the earlier procedure, we will calculate the DSI first for this beam, sorry, for this frame. So DSI, degree of static indeterminacy. So degree of static indeterminacy is equal to what I have given. So degree of static indeterminacy is equal to number of support reactions, minus number of equations. Okay, so now we have to calculate how many number of support reactions are here. So two supports are there, and these two supports are hinged supports. So for hinge supports, how many reactions will be there for each supports? So one is the vertical reactions, Va is here, and another is the horizontal reaction, that is Ha will be there. So Va and Ha, vertical and horizontal, there are two reactions are there for this hinge supports. So here movement will not be there, because movement will be generated at, at only fixed support. Are you getting? So here hinge support is there. So vertical reaction due to this vertical 200 kilonewton load, and horizontal reaction due to this 100 kilonewton load. So for at this A joint, Va and Ha, these two reactions are there. Similarly, at joint D, again here hinge support is there. So here Vd is the vertical reaction, and HD is the horizontal reactions. So again here two reactions are there. So how many total number of support reactions are there? At A and D, total 4 number of support reactions are there. Are you getting? So now this is the support reactions, number of support reaction. Now number of equations. So number of equations are again 3. If we have to check the stability of any structure, at least three equations we have to solve. Summation of m is equal to 0, summation of v is equal to 0, and summation of h is equal to 0. Then our structure will be stable. So number of equations are 3. So DSI is 1. So here DSI is 1. So now number 2. So we have to calculate the number of plastic hinges. So how many number of plastic hinges will be formed for this frame? So number of plastic hinges is equal to DSI plus 2. So here DSI is 1, and we have added 2 for what purpose? Here we have added 2 for at least 2 plastic hinges should form. Then and then we can go for the plastic analysis. So here 2 plastic hinges, minimum 2 plastic hinges should form. So here number of plastic hinges is equal to 1 plus 2, that is 3. 3 plastic hinges will be formed here, and these 3 plastic hinges कुठे कुठे फॉर्म होणार आहेत बघा. At this joint, at this 200 kilonewton point load, and at C, at B, at C and 200, या 3 ठिकाणी प्लास्टिक हिंजेस या ठिकाणी फॉर्म होणार आहेत बघा. by calculation here 3 plastic hinges are there. Are you getting? So now in third, we have to calculate minimum possible number of mechanism. Minimum possible number of mechanism. So किती minimum mechanisms आपल्याला solve करावे लागतील? That minimum possible number of mechanisms are number of plastic hinges minus number of plastic hinges minus DSI. So number of plastic hinges are 3 and DSI is 1, so is equal to 2. So minimum 2 number of mechanisms we have to solve for the plastic analysis. So if we have to do the plastic analysis of this frame, so at least or minimum 2 mechanisms we have to solve. So first mechanism is the beam, and second mechanism is the column or sway. Okay, so here 2 mechanisms minimum we have to solve, and combination of beam plus 1, that is the third mechanism we have seen in the type of mechanism, combined mechanism, that also we will solve. Okay, so now first is the beam mechanism. First is the beam mechanism. So now Now this beam mechanism, for which span beam mechanism is there? So for span BC, BC is the horizontal member, and at horizontal member, on the horizontal member there is a 200 kilonewton load at a distance 2 meter from B support and 3 meter distance from C supports. So this is the beam and 200 kilonewton point load is carrying. Okay, so for this beam, first mechanism we are going to solve. So see the frame here, horizontal member. So we are calling horizontal member in the portal frame as a beam and vertical members are as a column. So this is the this horizontal member, BC horizontal member is the beam. So for first mechanism we have to solve, that mechanism is the beam mechanism. So now draw the mechanism as per the our earlier procedure, because we have solved 4-5 examples on the beam mechanism. So here draw the mechanisms. So here rotation is theta. For this 2 meter span, rotation is theta. So now for this 3 meter span, what is rotation here? काय असेल rotation या ठिकाणी? So this 200 kilonewton load is acting at a 2 meter distance from B support and at a 3 meter distance from a C support. So the rotation for this 2 meter distance is theta. Then the rotation for this 3 meter distance is, we have to take theta 1, because the rotation will not be same for this 2 meter and 3 meter span. So now again this rotation is theta and this rotation is theta 1. Okay, now support B and support C. So at support B, if we consider the support B, here which type of support is there? This is the frame. This is the B and this C. Which type of support is there here? Anyone can tell me? End supports are hinged. Both end supports are hinged. So this is the continuous over up from A to D. This is B, this is C. A, B, C, D. The portal frame is A, B, C, D. So at B and C, this is the continuous support. These two are the continuous supports. Are you getting? Because at A, simple support, hinge support is there. At D, again hinge support is there. And B and C, these two are the continuous supports. So at continuous supports, hinge will form or not? As I told you, B and C compulsory या ठिकाणी hinge form व्हायलाच पाहिजे. Then and then we can go for the plastic analysis. जर hinge form नाही झाली तर plastic analysis आपण करू शकत नाही. Are you getting? So at B and C, always hinge will form. In the frame at B and C, always hinge will be formed. Okay. So now here at B, here hinge will form. So here moment will be generated. Again at C, hinge will be formed. Here moment will be generated. So here MP will be there. Again here MP will be there. Again here MP is there because point load is there. Again MP is there here. Okay. So this is the mechanism, beam mechanism. इथे का लक्षात सर्वांच्या? Minimum 2 mechanisms we have to solve. Out of this, first is the beam. So we have solved, or we have drawn the mechanism for this beam. Now we have to solve as per earlier procedure. As per our earlier procedure, we have to solve this beam mechanism and find the collapse moment. So we have to solve, or we have to calculate the external work done. So how to calculate external work done? External work done is equal to force into displacement. Any work done is equal to force into displacement. But here external, EWD. So due to external force, whatever work done will be happen due to external force, that is the external work done. So external work done, force into displacement. So what is how much external force? The external force is 200 into displacement. This displacement 2 into theta, 2 theta, 2 theta is the displacement, or we can write 3 theta 1. So here 400 theta is the external work done. Are you getting? Here external work done is the force into displacement. So force is the 200 kilonewton and displacement is the 2 theta. So total 400 theta. So now internal work done. Calculate internal work done. Okay. So internal work done is nothing but again force into displacement. So due to this external force, the internal force is generated in the terms of movement. So movement, how many movements are here? So there are 4 movements are there. So MP is the movement into the displacement is the rotation. For this movement, the displacement is rotation. So movement into this rotation, first theta plus second moment MP into this theta. Third, this MP into theta 1. And fourth, again MP into theta 1. So 2 MP theta plus 2 MP theta 1. This is the internal work done. So but here theta and theta 1, two different rotations are there. So we have to convert this theta into in terms of theta, theta 1 in terms of theta. So but 2 theta is equal to 3 theta 1, correct? Here if we see this beam mechanism, the displacement is same for 2-meter span and 3-meter span at rotation theta and theta 1. The distance is 2 meter here. For this, for 2-meter distance rotation is theta, and for 3-meter distance rotation is theta 1. But for these 2 theta and theta 1, the displacement is same. So 2 theta is equal to, we can write 2 theta is equal to 3 theta 1. Okay, and now calculate theta 1. Theta 1 is equal to 2 by 3 theta. So how much value? 2 by 3 is nothing but first. Now by using virtual work method principle, virtual work method principle. So by using virtual work method principle, external work done is equal to internal work done. So external work done is 400 theta and internal work done is the 2 MP theta plus 2 MP theta 1. So how much value of theta 1? So this is 2 MP theta. So value of theta 1. Tell me fast. Theta 1.